Lesson number 12, Equilibrium of Forces. Look at the figure 3a. You can see that two boys are pulling a rope. If the boys are exerting the same force on the rope will not move into any direction. In a situation like this, we can say that the rope is in equilibrium. Look at the figure 3b. A vessel is on a table. Here, the weight of the object is acting vertically downwards and perpendicular reaction force is exerted vertically upwards by the table. The vessel is in equilibrium under the action of these two forces. Here in the first picture, you can see an object is at rest on a table. So, what are the forces acting on it? One force is going to be downwards. It's the weight of the object, which is denoted by mg, and the perpendicular reaction exerted by the table, it's acting upward, vertically upward. That is denoted by capital N. So as these two forces are going to be equal and in opposite direction, and all the forces are going to be in same plane, the object is going to be in equilibrium. Look at the second picture. If we hang something on a scale, there are also two forces acting on it. One is going to act on downwards because of the weight of the object, and the other is going to be act upward, that's the tension of the scale. So as these two forces are going to be equal and in opposite direction and in the same plane, that object is going to be in equilibrium. Now we will see how an object is going to be in equilibrium under three parallel coplanar forces. So look at the first picture. You can see a bunch of banana is going to hang on a horizontal rod, and this rod is going to be suspended by two strings at the end. So you can say that there are three forces acting on this thing. Two forces is going to be upwards on the strings, and one is going to be downwards because of the weight of the banana bunch, right? So in order to be in equilibrium, the weight of the banana bunch has to be equal to the two forces acting on the rods upwards. Look at the second picture. A boy is sitting on a swing. He is in equilibrium. His weight is going to be acting downwards, which is denoted by W, and two forces are acting on the strings in upwards, F1 and F2. So, in order to be equilibrium, the F1 and F2 should be equals to capital W. Now we'll see an object which is in equilibrium under three forces, but they are not acting parallel. So if we take an example like hanging a picture on a wall. So this picture is going to be hung by two strings, and the forces acting on the two strings are not going to be parallel. And there is another force acting downwards, the weight of the picture. Right? So if we take these three forces, we can say that these three forces are not parallel. Right? So how this picture is going to be in equilibrium? You can see that if the two forces are not acting parallel, that means the forces acting on the two strings, they should meet a common point. You can see that common point in the second picture, which is known as the intersecting point. So among the common point, the resultant force of those two forces are acting upwards. So this force should be equal to the weight of the picture, which is acting downwards. So if those two forces are going to be equal, that object or this picture is going to be in equilibrium.